Hello everyone, how are you? I hope you all doing great. So welcome to EDS, multi-online education platform. So here you can learn something by expert tutor. So there are live online classes are there. So before starting our session, let me introduce myself. I'm Uday Kiran. I'm your maths academic specialist. I'll introduce our features tools you have. So you have chat option with you. You can interact with me through chat in the live session. And there are expert tutors are there. So you can ask any doubts and clarify your doubts. Still, if you have any doubts in that, so after the class, you have recording sessions are there. So watch all the recording sessions, and you will be provided with the exam preparation material, each and everything. So you just practice and revise all the concepts. That's it. You can ace any test. Okay. So yesterday we discussed about real numbers. Operations on real number and their decimal expansion. Okay. So today we'll solve exercise part. So first of all, thanks for being here in my class. Let's do the exercise sums. Okay. Let's get start our session. Uh, I think the screen is visible, everyone. All right. So in real number, we discussed about Euclid division lemma in the first session, and yeah, I got a great participation from everyone. So Euclid algorithm. So finding HCF. These things already we completed, and we completed the exercise 1.12. The second concept will be fundamental theorem of arithmetic. So fundamental theorem of arithmetic, you just write the natural number, the product of primes here like this. Like a tree structure. Product of primes is nothing but you can write like this. And we also finding HCF and LCM. HCF into LCM is equal to product of two numbers. So we already did a lot of sums in there. All right. So yeah, now revisiting real numbers and their decimal expansion. So what we did in the previous class. Okay, for your reference, I'm doing one sum. Okay, let's do the decimal expansion. How can we? So we just write in the form of 2 power n into 5 power m. This is what we learn. And yeah, so yeah, we learned about if it is in the form of 2 power n into 5 power m, then it is terminating. Okay. Yeah, here the question is the rational number has terminating decimal and non-terminating decimal, or else repeating decimal. They're asking for. So first, for your reference, I'm doing one sum here. Observe carefully, guys. We already completed exercise 1.1 first Roman. Let's do the let's do it the sum this one. So 23 by 2 cube into 5 square. So here in the denominator that is in the form of 2 power n into 5 power m, 2 power n into 5 power m. So that's why, one second, guys. Okay, so that's why 2 power into 5 power m. That's why it is a what we can confirm that it is a rational number. So it is a terminating decimal expansion. Okay. If you take an example of this one, 17 by 8, 17 by 8. So write the prime factors was 8. That is 2 into 2 into 2. So you'll get only 17 by 2 cube. So there is no 5 terms is there. Factor of 5 is not there. So that's why it is non-terminating and recurring. Okay, non-terminating and repeating decimal. So we already solved these things without doing long division. Without doing long division, we can solve this like this. Now move on to the second question. Write down the decimal expansion of those rational numbers in question 1 above which have terminating decimals. Decimal expansion. Okay. Uh, okay. Previously in the question they asked for without doing actual performing long division method. You don't do any long division method. You just solve observe the denominator and simplify the denominator. Then you can confirm it is a rational or irrational or like that. But in the next question they asked for so without decimal, so we can write decimal expansion of rational number in the question 1. We can take the question 1 questions also and which have terminating decimal expansion. Terminating decimal expansion is nothing but so it is a rational number. Okay. Let's start with the second sum. Yeah, I can second sum. Let's start with the first one. Okay, the same question. There is no question here. All the questions would be in the question number 1. Question number 1, it is 13 by 3125. 13 by 3125. Let's do the actual division here. So 13 by 3125, how can you do this? So 3125, you just do the normal division method, guys. 3125, 13. Okay, 13. So 3125 is a bigger number compared to 13. So you just multiply with 0. So you'll get 0 here. And 13 you'll get. If you put point here, you'll get 0. Still you are not satisfying. So you just multiply with 0. So you'll get 0 and 130. If you put point here, still the 3000 is bigger than. So that's why you just multiply with 0. 3125 into 0. So you'll get 0. Again, you'll getting 1300 and point is there. You just put point here. 13,000. Now 13,000 is bigger than 3125. That's why you can take, yeah, you can take 4. Okay, let's do the rough work here. 3125 into 4, you'll get 4 5 are 28, 10, 4 1 are 4, 5, 3 4 are 12. Okay, 12,500. It is less than 13,000. So that's why we can take 4 here. Now, what is the remainder we got? The remainder we got 5,000, I think. 5,000 or else 500. Okay, 500. I'm sorry. 500 we got. So by doing the long division method, somehow we have confused. So here point is there. You can put 0. Again, 5,000 is bigger than 3125. So let's take 1 here. Okay, I'm doing the remaining process here, guys. 5,000, 3125. Okay, I just continuing from here. The same answers, the same question. I don't have space there, so that's why I'm continuing from here. Okay, 3125, you'll get 1875, and already point is there. You can put 0. Now 18,755. So 3125, let's do the rough work here. 3125. Okay, 3 6 are 18 generally. So let's take with 18. So 6 5 are 30 and 6 2 are 12. 12, 15, 6, 7, 18 here. Okay, finally, yeah, we got 18,750 exactly. Okay, so you got remainder 0. We got remainder is 0. So let's take this quotient here. So that is the quotient we got 0.0416. But the question they here asking that uh, which have the terminal decimal expansion. Terminal decimal expansion is nothing but, so you'll get remainder is 0. You'll get remainder is 0. So that is terminating decimal. Remainder is 0. So that's why the first question it is a terminal decimal expansion. Why? Because you'll get remainder is 0. I hope everyone understood. If you couldn't get 0 here, you are doing like you are getting other numbers. So then in that time, so you just write that it is not terminating. Okay. I hope everyone understood how to solve the first one. Let's do the second one. So we have to do all these sums, guys. So be patient. 17 by 8. Second one would be 17 by 8. So here we have to do the long division method. All right. So 8 divided by 17. 8 2s are 16. 1.0. 8 ones are 8. 2.0. 8 2s are 16 again. Am I doing wrong? No. 4.0. So 8 5s are 40. So finally we get remainder 0. Remainder 0. So that's why if you get remainder 0, then the number would be terminating. So that it is terminated at, it is terminating decimal. Terminating decimal. How can we decide it is terminating decimal, sir? So if you get remainder 0, so we can confirm it is a terminating decimal. What is it? It is nothing but 17 by 8. 17 by 18, 17 by 8 is a terminating decimal at 2.125. So it just stopped at 5. So that's why it is terminated at 5. All right. Simple, right? So it is simple at starting, but if you solve the bigger question, then it might be complicated. Let's do the next one. Why? Because in the first two questions we are getting terminating. All right. 64 by 455 is the question. 64 by 455. Let's do some step, then you can understand. Okay. 455, 64. If you multiply with 0, so you'll get 0 here. 64, put point, so you'll get 0. 455 ones are 455. So you'll get 5 here, 5 here. 13 minus 5, you'll get 8. 5 minus 1, you'll get 1. So point here and again 0. 455 times 18, right? Let's take 5. It become 20. Okay, let's take 4. 4 5 is 20. 4 5 is 20. 22. 16, 17, 18. Okay, we are getting 18, 20. If you take 4, so 50 minus 20, you'll get 30. Again, put, okay, we can't put, okay, so you just put 0 here, but 455 is greater than. So that's why you just multiply with 0. So you'll get 0 here. Again, 300. Point is there, you just multiply 0. 455 into 30, right? 4 6 are 24, 7 7 are 28. Let's try with the 28. 4 5 are 35. 35, again 38. Okay, 4 7 are 28. 28, let's see, that is 3 1. Okay, it is increasing, right? So that's why I'm taking that 4 5 6. 4 5 5 6 into 6. So we'll get 2730. Let's substitute 2730. Okay, 2730. What we are taking 6 here. Okay, after subtracting 0 and 7, 7 9 2, 270. Again, point, put 0 here. Put point here. So 455 into, let's try with 6. 6 already 27770. So let's try with 5. 5 is nothing but 5 5 is 25, 27, 20, 22, 2275. So it was containing, I mean, we are getting the different numbers. Okay, there is no correlation. So we just stop it here. Why? Because it was continuing like this. All right. So we can write like 64 by 455. We can write like it is a 64 by 455 has a non-terminating, once again, non-terminating decimal. Why? Because we are not getting the remainder is 0. So that's why it is a non-terminating decimal. All right. We are getting some other numbers. So it was prolonging like this. That's why I just end up here after doing some steps. Okay, let's do the next sum. 15 by 1600. 1615. Okay, so if 1600 is greater than, so you just multiply with 0. So you'll get 0. 1600 into 0, 0. 15 you'll get. Put point. Again 0. It is not matching. Still, if you multiply with 0, 1600 into 0, you'll get 0. 150. And again put point. Again it is increasing. So 1600 also greater than 1500. So you just multiply with 0 again. So you'll get 0. 1500. Put point here 0. Now 15,000. It become 15,000. So 1600 into, let's try with 9. Let's try with 9. 0 0 9 6 are 54. 9 ones are 9. 9 14. Okay, 1400 400 with 9. With 9. Okay. So 14440. So we will get 600. 600. All right. Also point is there. So we just take it as one another 0. Now 1600 6,000. 1600 with 16 3 is a 48. Let's try with 16 4 is 64. Okay, let's try with 48. So you'll get 4800. So 4800 with 3. So we will get the remainder is 120 1200. Okay, so I'm doing here the rest of the process. Okay, let's do it here. Now 1200. So point is there. You just take another 0. Now 1600 into uh, let's try it here. 1600 into 7 is 00 42 711. Okay, so we are getting with 7. We are getting 11200. You can do some random things, guys. So 8 and 800 will get. So point is there. You can take another 0. You can do like this. Now 60 where I don't know where it stopped. So 1600 into 5. Let's try with 1600 into 5. 0 0 6 5 are 30 6 8. Okay, so 8000 we are getting. Finally, we got at 5. It just stopped here. Why? Because we get reminder is 0. So it is terminating. Okay, so initially by saying that I don't understand so where it stopped, and there is the stop. I don't think it has stop it or not. Okay, so there is a limit or not. Finally we got 69 into 5, that is 8000. Okay, so that's why it is a terminating decimal. The terminating decimal. Why? Because we get reminder is 0. If you couldn't get reminder 0, you just stopped after few steps. Okay, all right, let's move on to the next one. 29 by 343. Why can't we skip this question? Why? Because if you're doing all the sums, okay, let's do it here. Fourth one, we just started here. Okay, 343, 29, 29. 343 is greater than, that's why you just multiply 0. 343 into 0, 0. 29, put point 0. Still it is greater than, so just multiply 0. That is 0. 290 point here. So we just take 0 here. 343 into let's try with 8. 24 and 8 fours are 32 plus 34. Let's try with 34 here. 343 into 8. So we'll get 2744. 2744 into 8. So 2744 minus 2900. You'll get 156. Point is there. So you just put 0. Now 343 15. Let's try with 4. So 3 fours are 12. 16, 17, 12, 13. So 1372. All right. So with 4. Yeah, 1560 minus 1372. So you'll get 188. And point is there, you can put 0. 1800. 343. Let's try with, shall we try with 6? Okay, let's try with 343 into 5. 1715 with 5. So minus 1800. So you'll get 85. Again, point is there. So you put 0. 343 into 2. So you'll get 6, 8, 6, 686. Okay. 850 minus 686. So you'll get 164. Okay. So here what I'm saying, observing that. So it was continuing like this. 164 again putting put point 0. So it was continuing like this. So shall we confirm it as 29 by 343 is a non-terminating decimal. Why? Because there is no stop and there is no ending. That's why we can confirm it is a non-terminating decimal. Okay. So we just confirmed it like this. Let's move on to the next one. Okay. So 23 by fifth one, right? Sixth one. Finally, we are at sixth one. 23 by 2 cube into 5 square. Is that correct? Okay. 2 cube into 5 square. First, we have to simplify it. 2 cube is nothing but 8. 5 square is nothing but 25. 25 eights are, that is 200. Okay, now let's do the actual division. We just convert into a normal form because they're given prime factoration. So after doing the division, 200 into 23. So 200 is greater than, that's why you just multiply 0. get 0, 223, and put point 0 here, point and 0, 0, 1 here, 200 ones, 230, point 0, again 200 ones are 200, 100 you will get, put point 0, again 200 fives are 1000. Finally we got 0, at least one sum. So remainder is 0. If you get remainder is 0, then the 23 by 2 cube into 5 square is terminating decimal. Is a terminating decimal. All right. Let's move on. 129 by 7th one. 129 by 2 square 5 power 7. 5 power 7 into 7 power 5. 129 by 2 square is nothing but 4. 5 power 7. 5 power 7. So 5 into 5 into, let's write 5 power 7. 5 power 7. It is 78125. Okay, large number. And 7 power 5, that is 16,805. Okay, if we multiply all these numbers, so the denominator is a bigger number. The denominator is bigger number. So without doing that, so we can confirm as it is a non-terminating. Because the denominator is it is in lakhs and 10 lakhs like that. How can you say that? So how can you do this? So terminating, non-terminating decimal. Okay. So by writing this is the simple one, we have to write like this. Okay. All right. Now 6 by 15. 7th one, 8th one. 6 by 15. 15 is a small number, then we can do it. Okay. So 15 by 8. 15 by 6. So 0, 0. 6 here, put point here. 15 fours are 60. So simple, right? So 15 into 60. And 15 fours are 5s are. Yeah, 15 fours are 60. So we get remainder is 0. So that's why 6 by 15 is a terminating decimal. Terminating decimal. All right. Simple, right? So in the all the question, this is a simple question, I think. Next, 35 by 50. Ninth one. Let's try with 35 by 50. So 50, 35. So 50 is greater than. So that's why you just put 0 here. 35. Again, put point here. Point 350 you'll get. 50 into 7. So you'll get 350. Okay, this is also symbol. Finally, we got remainder is 0. That's why the question 35 by 50 is terminating. Terminating decimal. All right. Terminating decimal. Let's try with the last one, I think. Okay, 77 by 210. 77 by 210. Okay. 210, 77. So put 0, 77.0. Okay. 210 into 4 will get 800. I mean 880 like this. So let's try with 7. 210 into 7. So we'll get 1. No, 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 no. Once again. 770, right? So 210 into 3. So we'll get 630. I thought it is 7,000. Okay, fine. 0, 4, 1, 140. So 0 point is there. So just put point here. Okay, I just write it here, guys. 1400. And once again. Or else, better to do on the next slide. Better do in the next slide. Why? Because it is, I think it is a lengthy sum. 77 by 210 is the question. Okay. So 210, 77, 0, 0, 77, 0, 210 into 3, that is 630. 630, the remainder we got 14, not 14. Okay, 140, 140. Okay, here point is there. You just write point here. Now 210 into, let's try with 210 into 7. So we'll get 1470. So let's try with 210 into 6. So we'll get 1260. Okay. 0, 4, 1. Again 140. Okay. Now it is quite interesting. So you just put point here. So you'll get 77 divided by 210. Okay. Again 6. Why? Because 210 into 6. So you'll get 1260. 210 into 7. So you'll get 0, 7, 14, 1470. It is increasing, right? That's why we have to take 6 here again. 1260. Again 140. Can put bar. So again 6. 1260. Again 140. Put point here. 1260. So again 140. So it was continuing like this. 6, 6, 6, 6, 6 like this. Okay. So this is the new question, I think. So we are getting the answer 0.36 bar. So 6, 6, 6, 6, 6. It is continuing like this. So that's why we can put bar on 6. If we put bar on 6, the question 77 by 210. So we can confirm as it is at a non-terminating decimal. Non-terminating decimal. I hope everyone understood. All right. Okay, let's move on to the next question. Okay, we just done with the third question. Second question. Now third question. Let's do the third question. First, we just write the question first. Third one, first one. 43.123. 1, 2, 3, 4. 1, 2, 3, 4, 4, 5, 6, 7, 8, 9. Okay, so they given normal number 5, 6, 7, 8, 9. Okay, so one like this. Okay, they don't given any so on. Observe carefully the following real number. Now let's see the question. The following real numbers have decimal expansion as given below. In case, decide whether they are rational or not. How can we decide whether they are rational or not? If they terminated here, if they, I mean, let's we take the number 3.142. So it is terminated here. It just stop it here. Okay, 3142. We can write it like by 1000. It is in the PYQ form. So that's why it is a rational number. Similarly, the question 4.3142, all those things they given. So here it is terminated hit here. After 9, there is no dot 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 like nothing else. And we are not seeing any bar in the question. So that's why 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. After the point 1, 2, 3, 4, 5, 6, 7. 9 decimals are there, 9 decimals. That's why 1, 2, 3, 4, 5, 6, 7, 8, 9. So you just write in the form of P by Q. That's why, and Q not equal to 0. That's why the given number 43.1245, all those things is a given is a rational number. Given is a rational number. I hope you understand. Why? Because after 9 there is nothing else. It just terminated at here. It just terminated at here. So in the question they asked for the real number, they are terminating or not. If they are rational number, then we can write in the form of P by Q. That's why I'm writing in the form of like this 43 by this 9 digits. Okay. Okay, fine. Now let's move on to the next question. Third question, second one. Third question, second one. All right. 0.120, 120. Okay, 1200, 12000, 1240, and it is continuing so on. Observe carefully, guys. Here, we can't put bar anywhere. We cannot put bar in anywhere. So that's why. So 120 here and 1200. I mean 120, 1200 and 12,000 and 1 lakh 2,000 like this. It was terminating like this. So that's why we can confirm as it is. So we can't write in the form of P by Q. So it is non-terminating. Can I write repeating or else non-recurring? How can you decide way, sir? How can we write as recurring or non-recurring? Observe here, recurring is nothing but so 3 point in the previous question we got 3.6666 like this. That is 3.6 bar. If you put bar, that is repeating. Why? Because 6 is repeating. But here there no number is repeating. That's why we can write It is non-terminating and non-recurring. It is not repeating. So that's why. So it is a number. The number it is a it is an irrational number. The question whatever the given is an irrational number. Okay. All right. Let's move on to the last question. 43.12345. Okay. Again bar the given. Third one. 43.123456789. Like a okay. So this is the question they given 1 2 3. Okay. Here they put bar here. What I told you. If you put bar here, so we can write clearly it is. First, we can confirm it is non-terminating. Why? Because we couldn't get 0. Non-terminating. But here we are putting bar, so that's why it is repeating. It is repeating. It is repeating. So can I write? Can we write in the form of? Now we can take whether it is a rational number or irrational number. It is a rational number or irrational number. It is a rational number, guys. It is a rational number. Why it is a rational number, sir? For 43.12345, sir. So it is repeating like this. So before that, so before the slide, you saying that if you repeating like this, so you are saying that it is a rational number, sir. Then now you why you can't why you are saying that it is a rational number. So in the previous concept, we learned about how to convert that bar in terms of rational number. In the previous classes, we already learned, right? And also the rational number conditions are the rational number conditions are. So first is terminating, and second one is non-terminating and recurring. So these are the conditions for rational number and repeating or recurring, whatever. All right. So these are the conditions for rational number. For irrational number, only this is the only condition for irrational number, non-terminating and non-recurring. This is what already we learned in the previous session, right? All right. So from here we just end up the session and we end up the real number concepts, all the real number. Okay. So that is the end of the chapter. We already solved each and everything. And let's summarize the session, the complete chapter. First, we started with the Euclid division lemma. In Euclid division lemma, so you should write A is equal to BQ plus R. A is equal to BQ plus R. Here, A is nothing but dividend, and B is nothing but divisor, and Q is nothing but quotient, plus R is nothing but remainder. This is what I mean. We are comparing with that Euclid division lemma and the division algorithm, both are similar. And what is the condition here is, so 0, the condition is very, 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 very important. So this is what we learned the first concept, Euclid division lemma. Okay. Now Euclid division lemma algorithm, we have to find the HCF. How to find the HCF? So we just do the division method and write the coefficient. I mean the remainder, all those things. So we already solved all the questions. And fundamental theorem of arithmetics. So we just write in the terms of prime factorization. Prime factorization, let's take the 32. We just write in the product of primes, that is 2 into 16. And 2 into 16 we can write as 2 into 18, 288. 2 into 2 into 2, 8 we can write 2 into 4. So 2 into 2 into 2 into 2 to 7. So finally we can write 2 power 5. Here 2 is the prime number. So you just convert the whatever the question in terms of prime factorization like this. Okay. So this is what we learned about fundamental theorem of arithmetic. So you just write as a product of primes, as a product of primes. All right. Now the decimal rational number, whose decimal expansion? Decimal expansion, what we did in the decimal expansion. So if the decimal number, let's take 13 by 255, observe the denominator. The denominator you just write in the prime factors. So if it is in the form of 2 power n to 5 power m, then it is terminating. If it is not in the form of this, like, so we called as non-terminating. This is what we learned about, 2 power n into 5 power m and nm are non-negative integers. About decimal expansion of terminating. All right. Yeah, these are the conditions for each and every condition for decimal expansion. And finally, the concept we learned about. Yeah, these are the formulas. HCF into LCM. That is the important formula we missed. Fourth one. So if they given LCM and HCF and two numbers, we can write it as product of two numbers. We already solved. Okay, LCM into HCF is equal to product of two numbers, that is A into B. A into B. Okay, we already solved all the questions. If they anything else, anything we missed? I think already we covered all the examples and each and everything, right? I hope. Yeah, you can do the terminating and non-terminating concept. Terminating is nothing but the word terminating is nothing but if you get remainder is zero. If you get remainder is zero, it is terminating. Okay. And second concept, non-terminating. So the remainder is not equal to zero. Okay. Now the third one is non-terminating, and recurring. Non-terminating recurring. The example would be 3.6 bar. So 6 is repeating like this. So that's why we can write it as recurring. And non-terminating, and non-recurring. For example, so the example in the previous question, 4.1, 2, 3, 4, 5, 6, 7, 8, 9. Again 1, 2, 3. Sorry, 1, 2, 3, 5, 6, 8, 9, 4, 2. So we are getting some different numbers. Okay. So there is no end. It is continuing like this. We are not able to put bar, what we did in the previous one. We are not able to put bar here. So that's why we called as non-recurring. The word is non-recurring. These are the types we already discussed. All right. I hope you everyone understood what we discussed till now about all the concept. Still, if you have any doubts in the concept of real numbers, any Euclid division lemma or anything, so you just do one thing. So you just revise all the topics and see all the previous videos. Okay, then you can understand each and every. Why? Because we are following the textbook, and also we did all the example sums also. Example sums and also previous asked questions and exercise sums. And I personally given some examples sums for you. Whatever, if they given the question like this, then what you'll do. So I given like that, and we write the important points. How can we define rational number, irrational number, and all those things? What is terminating and non-terminating? So just now we discussed, and operations on real numbers. All the things we already covered. Do one thing. So you just see all the material and also see all the videos once again. Okay. Yeah, I just end up here, guys. Thanks for being here in my class. I truly enjoyed the session. I hope you enjoyed also. Okay, learn something in the session. If you couldn't learn anything, so it is not useful anything. Okay, so try to revise all the concept and practice more question this particular, and you should be master in it. If you practice and revise all the concept, you should be master in it. Okay, do like that, and yeah, bye bye everyone. So let's end up here. Have a good day. Okay.